Good morning, gentlemen. Today is Monday, March the 30th, and today we're going to talk about section 10.2, the center of mass. Now, remember on Friday we talked about the concept of center of gravity. And since we know that gravity acts on the mass of an object, generally speaking, for most objects, the center of gravity, or what you see there as CG, is the same thing as the center of mass. However, there are some exceptions, right? For example, if you're talking about a very, very tall building, like the Empire State Building or the Freedom Tower in New York City, in that case, there is actually a small, teeny tiny difference in the location of the center of mass and the center of gravity. And the reason for this is that the bottom of the building is closer to the surface of the Earth, and therefore the gravitational pull on the bottom of the building is actually somewhat greater than the pull of gravity on the top of the building. And so the center of gravity may actually be a little bit lower than the center of mass of the building because gravity is again acting differently on different parts of the building. All right. So if let's say this thing, I don't know what this is one of my kids' toys, but if this represented a very tall building, all right, gravity works more here and less here, because this point is further away from the surface of the Earth. Now the center of mass is going to be right in the middle of the building, wherever it happens to be. But the center of gravity might be a little bit lower because it's the bottom of the building is being pulled more than the top of the building. This becomes even more apparent in very large objects like a solar system, because in this case, now remember that the sun is a big, massive ball in the middle of the solar system, and the planets are here and here and here and here and here and so on. And so the center of gravity for most solar systems is somewhere inside the center of the star. The star generally is the largest object in a solar system. But the center of mass is going to be located outside the star, because the mass of the system is spread all throughout, from the sun and in the case of our solar system, all the way out to Pluto or even beyond. And so this is something that astronomers can use to identify solar systems or stars that actually have planets around them, because the star itself will actually move as the planets orbit them. All right, they'll wobble. They'll move toward where the center of mass might actually be. So stars appear to wobble because planets in orbit around them move the center of gravity to a point outside the body of the star. All right, gentlemen, that's all I've got for you today. Have a wonderful Monday.